Hello, in this video we are going to try to learn conjugate of a complex number, and also we'll try to divide two complex number. Okay, so let us see how we can find conjugate of a complex number. So first of all, let's look at any generic complex number z. So we know that z I can represent a plus bi for. All right, so that is a standard form of a complex number. Now if I want to find conjugate of z, okay, so I want to find what? Conjugate of z. Conjugate of z is represented by using a symbol z bar. Okay, it is going to be keep a as it is and change the sign of the complex portion. Okay, so if I change the sign for plus, it will be minus bi. Okay, so this is the complex conjugate z for the complex number z. Okay, so that's how we find complex conjugate. Okay, let's do some problems, so in that way it will be more clear to us. Okay, now let's say I have a complex number a, which is z equals 2 plus 5i. Okay, what is my objective? Is my objective is I have to find z bar, and also I need to find the product z bar. Okay, so I am multiplying what? A complex number with its conjugate. So similarly I am going to solve another problem b, where my z is equals 1 minus 3i. So in this case again I have to find the complex conjugate of this number, and I'm also need to find, that means I need to multiply this complex number with its conjugate. Okay, and let's see what happens. So let's start. So first of all, for if I want to find z bar conjugate for this particular problem, I'm going to keep the real number as it is, which is 2, real portion. Now the imaginary portion is positive 5i, and I need to flip the sign, so it will be negative 5i. Okay, so this is my z, that means conjugate number. So let's try to multiply z with z bar. So the complex number is what? 2 plus 5i, and its conjugate is what? 2 minus 5i. And again, as you can see, this is multiplication of two complex number, and we did it before, and we are going to use FOIL method. So what I'm going to do, I'm going to multiply these two with these two, so it is going to be 4. And I'm going to multiply these two with negative 5i, so it will be negative 10i. Okay, now I'm going to try to multiply this 5i with this 2, so it is going to be positive 10i, and this 5i with this negative 5i, so it will be negative 25. So it will be negative 25. I multiplied by I is I square. All right, so let's see what I am left with. Now as you can see, 4 is 4, fine. Now negative 10i, positive 10i cancel out each other. Now here I have what? Negative 25, and I square, we know that I square is negative 1. So I got 4 plus 25. Now if you notice, I can write actually this 4 as 2, so this is actually 29, as you can see. So so just keep in mind that the multiplication z bar, that means multiplication of the complex number with its conjugate, I get 29, a plain number, no complex. Okay, so again let me try to write that 4 is actually 2 square plus 25 is 5 square. Okay, and just to let you know that these two I can say a plus this 5, I can say it is b. So anyway, just keep it in mind, we will use it later. Okay, just hold on a second. So anyway, now let's look at our second problem. So here my z is given, the complex number 1 minus 3i. So if I want to find z bar, which is the conjugate of that complex number, so the real portion is going to stay same, and the imaginary portion, it is going to flip the sign, so it will be positive 3i. Okay, so now let's try to multiply z with z bar. Okay, so what I get z is 1 minus 3i, and it will be 1 plus 3i. Okay, so let's do again FYL method. So 1 multiplied by 1 is 1 square. 1 multiplied by 3i is what? Positive 3i. Now negative 3i multiplied by 1 is negative 3i, and negative 3i multiplied by positive 3i will be what? Negative 3 square, and I multiplied by I is I square. So what I get 1 square, and positive 3i and negative 3i cancel out each other, and then what I'm left with, negative 3 square, and I square, as you know, is negative 1. So I get 1 square negative, and that negative positive, so positive 3 square, so which is actually 10. Now the most important thing we need to take it from these two problem is, whenever you multiply a complex number with its conjugate, I get a real number, so no complex involved. Again, when I multiply this complex number with its conjugate, again I got this a real number, no complex involved. Okay, and so in general, so I can say if z equals a plus bi, and of course the complex conjugate is what? A minus bi, then z multiplied by z bar, which is will be a square plus b square. As you can see, again this is also a square plus b square, so it will be a square plus b square. Okay, so remember that we are going to use this fact whenever we are going to deal with two complex numbers. So that is actually a introduction and to problem solving regarding conjugate. Okay, now we are going to try to divide two complex number. Now dividing two complex number is also pretty simple and easy, so let's start. Okay, so dividing two complex number. So dividing two complex numbers. So let us start with a simple one. Okay, so we need to divide this complex number, two complex number, which is 3 plus 5i over 1 minus 3i. Okay, so we are going to divide these two complex number. Now as you see from these two complex number, here my denominator is also a complex number. Now when my denominator is a complex number, we cannot do any mathematical operation. Okay, so we need to try to see how I can convert the denominator to a real number. Now the key is here. As you can see, if I, as you know, if I multiply a complex number with its conjugate, then I got a real number. So I am going to apply this principle. So what I am going to do, I am going to keep my original two complex number, and here it is 1 minus 3i. Now look at here, my target is what? To make sure my denominator is a real number. So if I want to make denominator real number, I want to make sure that I'm going to multiply the denominator by the complex conjugate of this number. So what is the complex conjugate of this number? 1 plus 3i. So now I need to also multiply the numerator also 1 plus 3i. Now you see, so I am not changing anything. Okay, so now let's look one thing. So this is a complex number with its conjugate. So when I multiply, what I got, I am going to do a square plus b square. So in this case, a is what? 1 square plus b square is 3 square. Okay, so that is the denominator. Okay, so let's, for the numerator, we am going to do in a FOIL method. So 3 multiplied by 1 is 3. 3 multiplied by 3i is plus 9i. And then 5i multiplied by 1 is plus 5i. And 5i multiplied by 3i is plus 15i square. Okay, so let's see what I got. I got denominator is 1 square plus 3 square is 9, so 10. Denominator is 10. So here I have 3 plus 9i plus 5i, which will be 14i, and plus 15, and I square is going to be negative 1. So I am getting, so 3 plus 14i minus 15. So I get 3 minus 15 is negative 12 plus 14i over 10. Now let's so it is negative 12 over 10 plus 14 over 10i. So this is the dividing two complex number, and as you can see, these two complex number are what form? A plus bi form. So just to let you know. Okay, so this is our first example. Okay, so let us try to do another example just to see how we can proceed. Okay, now let's say I have a, so let's try to do, so let's say I have 4 plus square root of negative 25 over 2 minus square root of negative 9. Now as you can see, these two complex number are not using a symbol I, so we first need to make sure that we are dealing with I, because it is going to make our life easy. So let's do, so 2 minus, we did it before, so that will be 3i, and 4 plus square root of negative 25 is 5i. Okay, so we converted into this two complex number. Now as before, I am going to do what? So I want to make sure that my denominator is a real number. So let me write it down again. 2 minus 3i, and then 4 plus 5i. So as I am going to make sure my denominator is a real number, so I am going to multiply the denominator by its conjugate. So what is its conjugate? It is going to be 2 plus 3i, and of course I'm going to use the numerator also, 2 plus 3i. Okay, so now let's multiply. Now the denominator is easy, so because this is multiplying to one complex number with its conjugate, so it will be a square plus b square. So a is here 2, so it is 2 square plus b is 3 square. Okay, so now let's multiply first. So 4 multiplied by 2 is going to be 8. 4 multiplied by 3i is going to be 12i. Let's do the other one. So it will be 5i multiplied by 2 is going to be plus 10i, and 5i multiplied by 3i is going to be 15i square. Okay, so let's see what I am left with. 2 square is 4 plus 3 square is 9. Okay, so 8 is 8 here. 12i and 10i is going to be plus 22i, and plus 15i square is negative 1. So what I am getting is 4 plus 9 is 13, 8 is 8, plus 22i minus 15. So I am getting 8 minus 15 is going to be negative 7 plus 22i over 13, and as I am going to so negative 7 over 13 plus 22 over 13i. So this is in the form of a plus bi form. So this is in a plus bi form. So that's how you divide two complex numbers. So that will be the end of this section. So I'll see you in next video. Thank you.